If we're going to determine the concentration of 4 grams of sodium hydroxide dissolved in water, and it's 200 centimeters of cubed of water, I first need to change that into 0.2 decimeters cubed, and I need to get the molar mass because I've been given a mass of sodium hydroxide. So that's 40 plus 16 plus 1, 23 plus 16 plus 1, which turns out to be 40. So we can go number of moles is equal to mass over molar mass, which is equal to 4 over 40, which becomes 0.1 moles. But we're not looking for moles, we're looking for concentration. Concentration is number of moles divided by volume. 0.1 divided by 0.2, and I land up with 0.5. And either I can put a capital M there, or I can say moles per cubic decimeter. The next one, 17 grams of silver nitrate. So I'm going to need to work out firstly what silver nitrate is, and it is Ag. Silver has a valency of 1. Nitrate is NO3. NO3 has a valency of 1. Hold hands, and you land up with AgNO3. The molar mass of that is going to be 108 plus 14 plus the 3 times 16 over there, so you land up with 170. And then if you want to get your number of moles is equal to mass over molar mass, which is equal to 17 divided by 170, which equals 0.1. And then when I want, that's moles. And by the way, quite a few of you were putting a -1 there for moles. It's not per, it's only moles per cubic decimeter. It's not per mole, it's moles. A little -1 there means you're dividing. It's not correct. So you go concentration is then equal to number of moles divided by volume, which is equal to 0.1 divided by 0.5, and I land up with 0.2 moles per cubic decimeter. And finally, on this page, calculate the concentration of the solution where 49.08 grams of magnesium sulfate with waters of hydration. Remember, you add those waters of hydration. So when I'm looking for the molar mass of that whole thing, it is equal to 24.03 plus 32 plus 64 plus 7 times 16 plus 1, which is 18, which is the water, and I land up with 246.03. So number of moles is equal to mass over molar mass. They give me 49.08 divided by 246.03. I land up with 0.2 moles. But that's not my concentration. My concentration is number of moles divided by volume. So it's 0.2 divided by 750 centimeters cubed is 750 milliliters. So I need to change that into 0.75 decimeters cubed by dividing by 1,000. And I land up with an answer of 0.266 moles per cubic decimeter. Now we've got the sample of calcium chloride. We need to get the molar mass of calcium chloride. Molar mass is equal to 40 plus 35.5 plus 35.5, so it's 111. Number of moles is equal to mass over molar mass. It's 22.2 divided by 111, and we get 0.2 moles. Concentration is number of moles divided by volume. So I land up with 0.2 divided by 0.5, and that gives me 0.4 moles per cubic decimeter of the whole solution of calcium chloride ions. They then go on to say, what about the calcium ions? Well, for every calcium chloride unit cell or molecule in inverted commas, I have got 1 calcium. There is 1 calcium inside that formula. So whatever the concentration is of the calcium chloride will be exactly the same for the calcium. However, for calcium chloride and chlorine, I have got 1s2, and over here there are 2 chlorines in every calcium chloride. So instead of 0.4 moles, my concentration for just the chloride ions would be doubled.